Hey, so good morning and welcome to another day of adding data persistence to your web APIs. You might remember that we were working on this project, right? And we manually created using DB Browser for SQLite. We manually created a database that we call db.db3 and had a courses table that we could use, to persist data about courses using our API. So today, I'll show you a different way of creating that database. So let's go open it up. I guess we should have this one right here. And remember that we have this courses table, and it's got an ID and a name. One is an integer, the other one is text. So what if, I'll close this. And I'm going to tell you a little story. And this happened yesterday, as a matter of fact. So on my private company, I help them out sometimes when they have issues. Now they need to do a big refactoring on a really old piece of code. I'm talking 6-7 years old. So they want to do a quick refactoring on that. Well, not quick, but a refactoring on that. And I happen to have a test database, the development database that they use for doing development and testing, right? I have a copy of that I got a few months back, maybe 2-3 months back. So I cloned the repository, turned on the database server on my Windows computer, and I ran the software, and I started getting errors, so I could not run it. I'm like, why is it not running? Well, it turns out that they added 2 new fields to one of the tables, and now those 2 new fields, I don't have them on my database. So last night we got on the phone and it's like, okay, so let's see, what have we added in the last 2 or 3 months that you don't have? So we have to compare the databases, the version that I have with the version that they have currently. So the alternatives here is either they give me a brand new copy of their database, and this is from the Dominican Republic, and this is a big database, about 60 gigabytes, or I update my database so that the schema of my database looks the same as theirs. Now here's the problem though. Nowhere in the repository, as I did a pull, right, to update my 2 months old copy of the repository, and I pulled the new changes, nowhere in there did I find information about which fields I needed to add to the database. So the database and the system have been evolving. What normally happens is that you evolve your code and you push that to your GitHub repository, but the little changes that happen on the database, oh, we made this not nullable now, or maybe, and it was nullable before, maybe we ran an update on this and we changed the name of this field, or maybe we added a couple of fields. None of those things, the history of the code is perfectly fine and saved on your repository, but the history of the changes that happen to the database, they're not there. But not only that, okay, I can always go and say, hey, I'm gonna pull this branch. We have master, we have development, and we have feature branches. So I can go and pull the first branch that they created for doing this refactoring, maybe from a month ago. And it turns out that a month ago, the database may have been different when working on that branch. Fast forward a week, and maybe I want to move to a different branch or a different commit, and maybe the database changed in that week. How do we know? How can I know how was the database 3 months ago? So the solution that a lot of vendors has come up with is called a migration. And the idea here is keep a history of all the changes you make on your database with the same care that you give your code. Keep every change that you to the database together with the code or the version of the code that works with that version of the database. That's called a migration. So today, Let me see if I find this real quick. I had to restart my computer because you might remember yesterday was kind of slow. So let's go open this. So today we talk about migrations and seeding. And we also have a little bit about querying there, but we're going to start quickly into the Connects migrations and how to build schemas and evolve the schemas together with your code. This kind of reference here. So we'll see, we're going to do it together. And I want you to continue working with me on the same project that you were working yesterday, the zip file that I sent you. Okay. So let's see how the questions thread. All right. So it's empty. Cool. So it is really, really hard for you to see the value of this. Just trust me when I say migrations are important. So please try to learn how to do your migrations, because it's going to help you immensely in the future, right? Especially when you work with a team and with other people. So a couple of things we need in order to create migrations. And I want you to have a high-level overview of how they work. Let's keep the documentation for Connects handy. Because if you scroll down to the Connects, but go past the query builder and go all the way down to the schema builder, this is, remember that the schema is the structure of something, the structure of your table, the fields that you have and the data type and the size for each field, but also is the schema of the database. Like what are the tables, what are the store procedures, the views that you have in your database. So the schema builder here is going to let you do things like create a table, or maybe drop a table, maybe create a table and later come back and rename a field on that table, or maybe add a new field to a table or remove it. So you have a lot of helper functions in JavaScript, helper functions that are going to help you do that. Let's say that you wanted to create a table. Well, you have this create table thing that you could use. And this is part of the Connects schema builder. So what do we need? Well, first, we need to make sure that we have Connects installed and that we can run it from our terminal. So I'm going to ask you right now, just so we can start getting that out of the way, that you go and open that project we have been working with for the demo, and then on the terminal, type Connects with nothing other than just Connects. And I want to know if you get problems. Like, for instance, oh, look at this. I just got Connects options command, right? Let me make this a little bigger. Actually, just close this, place it on the right. Close that so you have a lot of, okay? So I type Connects and it's telling me, hey, the usage for this is Connects, you pass on options and then a command. And these are the possible options that we can use, and these are the possible commands that we can use. And really, it's basically 3 commands: init, migrate, and seed. That's it. Okay. And this red text is just telling me you haven't given me any options. So if you're having any issues running Connects and getting this message here, then let us know, because you will need them, or you just have to use npx Connects for the commands that we do only using Connects. So let's take a quick look at the commands that we have here. Well, we know what to do with init. This is going to generate our Connects file.js, this file right here. That's what that does. So the other 2 are migrate, and it's got some variations by adding this column, and then seed. Those are the other 2. So basically 3 commands is all you need to know about the Connects command line interface. So how do we use this? Well, the first thing we're going to do is imagine that we come into this project and we know that we're going to have this database, but I'm going to do something crazy, and I'm just going to go and delete this database right there. Boom, delete it. So we have no database now. The server is broken. But I do know what is the structure of that database. I wanted to have a courses table that has an ID and a name, and the name happens to be a string, right? That's what we did when we created that. So we're gonna do one command at a time, and I want you to do those commands with me so that you get the practice, and then we're gonna do it a few times. We wanna get the flow of how this works. We have no database, but we have an idea of the stuff that we wanna put on the database in the beginning. Like in the beginning, we wanna have a table called courses. So please go and delete your database, make sure that it's not there. An easy way to know whether that worked or not is if you go and try and run what I call mine server, right? I think. So let's use yarn server. Yep, definitely telling me, hey, oh yeah, right. I remember that I zipped this up, so did not include the node module, so I deleted those. Let's wait until those are installed. There you go. Now yarn server. Yep, but it's supposed to be working, right? So let's go and try it out with Postman. But if we try it out, we're gonna find out quickly that there's no database there. Let me make sure by revealing in the Finder that in fact that database is gone. Yep, it's gone. There's no database in there. All right, so any issues running connects or deleting the database? I also, as a safety measure, I also closed all of the instances that I had of DB browser for SQLite to make sure that nothing is blocking that file or locking it so that I cannot delete it. So it's a good idea to do that too. See some comments coming back. Still adding node modules. Yeah, those are kind of slow to download. Okay, so I'm gonna stop this server. And I'm gonna wait until we're ready to go. Ready to migrate. All right. Unless I see a no in there, I'm gonna assume that everybody is ready to go. Cool. All right. So the first step would be to create a migration. And we create a migration for every little change that we want to do to our database. Creating the database and creating a table in the database is a migration. In the case of SQLite, which is what we're using, by creating a table, it will generate the database. If you are working with a server database, someone else, probably the DBA that has access to do that, will create the database for you. It's going to give you username and password that you can use to connect to the database and give you the privileges if they will allow you to create tables and objects in the database. So if you have a username and a password to the server, they have to create the database first. It's not going to get created automatically. Connects cannot do that on a database server. On SQLite, we don't have that problem. So we could just say, hey, I want to have a courses table. So this is how we do it, right? The first thing we're going to do is we're going to come into the connects file, and I'll show you why. We're not going to do it right away, but I'll show you why. So I'm going to say connects migrate. And then remember that we have a few commands for migrate. The first one is make. So connects migrate make, separated by a colon, space, and then I'm going to give it a name. I'm going to say courses table. And it created a migration inside of this folder called migrations, and this is what I wanted to show you. By default, you will just add inside of your at the same level of your Connects file, it's going to add a folder called migrations, and in there, it's going to add all your migrations. But we can control that, though. We can provide options in our configuration object right here to do things like, I want to control the name of the directory where the migrations are going to go. So it would be cool, I could say something like migrations, and I could control the table name that I want to have on the database, because Connects is going to create a table in the database to know the migrations that as the migrations run, to know which migrations we already ran. So you could give it a name, but we could leave the default name, and then a directory. And in this directory, I could provide where I want this stuff to be saved. Let's say that I want to have a directory called data, and then in there, I want to have a migrations folder. So this is me telling Connects, don't create that migration out there, create it inside of this other folder in there. So I'm going to save that and run it again. Force stable, and then create it. Look at that. It created this data folder for me, and then inside that, there is a migrations folder, and now we have the migrations in there. So I'm going to delete the one outside. I love having anything related, either a database folder, a DB, or a data folder. So everything related to migrations should go in there. And even the database. See, the database is not created in there. So since we already have this data folder, let's do this. Let's say save my database inside of this data folder. So the data information and database information is going to be in that folder. There's no database created yet, but we are going to create one in a minute. Okay. So let's go and run that. Make those two changes right away. Add the migrations key with the directory. Give it any name you want, data, database. That makes sense to you. And also change the connection to point to that same folder so that we have the database at the root of that folder and then the migrations as a subdirectory in there. And let me know when you're done. So after you save those changes and run connects, migrate, make course stable again, the folder should be generated and there should be a file in there. We're going to look at that file in a minute. Cool, ready to go. All right. So, all right, we created a file, but what happened? What's in there? Let's go take a look, because I'm curious. I want to know what's in there. So if we go and open that migration, course stable migration file, you will see that it's got a couple of functions, and they happen to be on the exports object. So this is equivalent, just so you know, to module that exports equals an object that has an up function and a down function. Okay, only that we're using the exports keyword instead. So the idea is that this file is exporting a couple of functions, one that is called up and the other one that is called down. So who's going to execute those functions? Connects. Connects is going to run them. So whenever you say, hey, I want to run the migrations to modify the database, it's going to run this up function. And whenever you say, hey, I want to revert the changes that I just made because that didn't work, so I want to revert it back. I created this field and I don't want it anymore. I created this table, I don't want it anymore. I renamed this, I want to rename it back. So in those cases, it's going to run the down function. So this down function is like undo for your database, which is awesome for the structure of your database. So let's say it in action. Remember, we have no database. The data folder is only has the migrations. So let's go and create that table in there. I'll show you the commands. Then we're going to go and take a quick look at the documentation, like browse it a little bit, and then we're going to have you run it. Okay? So we have this promise in here. We don't need it anymore, but you can leave it there. And then we have an instance of connects. This is going to pass. This is going to be passed automatically by connects because, hey, here's the connects that you have configured. Okay, and this is going to take into account our configuration. Remember that configuration that we had? The connects file, it's going to take that into account, and by default, it's going to run it using the development environment, by default. But you can change that, and we'll learn how to change that as we deploy later on the project week. So for now, let's go and create a table. So how do we do this? Well, the first thing we need to do is we need to return from here a promise that connects is going to then work with. So we're going to say return a call to connects that schema. And then inside schema, not that, come on, Visual Studio. Inside schema, we have a lot of functions. One of those is create table. And this create table takes a couple of arguments. First is, what is the name that you want for that table? Courses. And then a callback function that's going to get an object that we can use to configure that table. So this is going to get like a table object passed in, and then we use that table object in order to configure all the fields and the stuff that we want on our table. So the first thing that we want is we want an ID, right? We want a primary key. And we want this primary key to be called ID. Turns out that Connects knows that most of the time you are doing this. So they gave us something that we could call on that TBL object that we get. We could call a method called increments. Just like that. And this, by default, creates an ID field that auto increments. And you can make it explicit, and you can say this is going to be my primary, like so. No need though. This will end up being the primary key no matter what. So just with that, if we ran that migration, it will have an ID field that auto increments. Oh, by the, yeah. Why is this? What is identifier expected? I don't know what that is. It's fine, trust me. There you go. Yes, so the question, very good question. Did we delete, oh, yeah, two questions. The first one is, did we delete I deleted the migration folder that was outside. I just wanted to show you how it works by default. So I deleted that and just kept the one inside the data folder. And the second question is, doesn't SQLite auto increments for us already? Yes, but we have to tell it. We want to let, we have, remember that we checked that box, said, I want you to auto increment this field. It doesn't do it by default. But this function, calling this method on the TBL, on the table object that we get passed, will do that for us. It's going to create an integer. It's going to be an ID. It's going to be auto increment. It's going to be the primary key. All that goodness for the primary key called ID is going to be by default. And we can even change the name. We could say, hey, I want this to be called course ID instead. And that will be the name of the field. No need, because it's going to be named by ID by default. So is this a way to change things manually? No, this is a way to generate our database from JavaScript. So instead of you having to open another tool like DB Browser for SQLite and creating a field, making it a number, an integer, marking the auto increment, marking it as primary key, all of that happens by just calling this method. Connects will do it for you. The beauty of this is, what happened to me wouldn't happen to the next developer. If I have my database described here as migrations, anybody downloading my repository now has this code, and all they have to do is run the migrations, and they're going to have a database up to the version of the code where you are. So if they pick up this version right now, they're going to get a table that has that ID. But as we add more, maybe in 2 months, we have a couple of other fields. Whenever they download from the repository and they run the migrations, they're going to have the database exactly as it was at that point in time. And this is huge. Okay. All right. So what else did we have? Well, we had a name field for the course. So let's go and add it. And the way that we add or modify data in the schema of our table is by calling methods on this TBL object that we get. This doesn't have to be called TBL, by the way, right? This is a table object that represents the table. I could call it whatever I want. But on this table object, we could say, I want to have a field that is going to save text. The way that you do that is by creating a string. So I'm going to say, I want a string field, and the name of the field is name. And then we could pass a second argument that which should be the size of the field. So let's say that we want this to be as big as, I don't know, 255 characters. What if I want to make sure that this is not null? Well, you could chain a code to something called not nullable. And now this is going to guarantee that this is not only created as a name, but it's also going to be not nullable. What if I want to have an index? Well, there are methods that we could call to turn this into an index. What if I want to later rename this field? Where there are methods, and this is supposed to be lowercase string. There are methods that we can call that will let us rename fields. What if I want to add another one? We just add it. So there are methods in the schema, and this is why I said I'm gonna show you how to create that table first, and then we're gonna go and like peruse the documentation a little bit, and then I'm gonna have you do it, right? So you don't have to do it right now. So remember, you want to be a good citizen with this. So what happens if later you decide that you don't want that table anymore? Well, you need to configure the undo for your database. It's called a rollback. So in databases, when you undo something, you say, I'm rolling back that change, okay? So in here, what did we do up here? What is it that the up is doing? What is it doing? I know you know. Ultimately, once I run this, what's going to happen? It's going to create a table. It's creating a table called courses. So in this case, what I want to do is drop that table. I want to say drop table if exists courses. So when I run the migration, it's going to create a table called courses with these fields. And if I roll back that change, I don't want it anymore, it's going to drop that table if it finds it. Save that. And I want you to look here. There's no database in the data folder. But then I'm going to execute a different command. I'm going to say connects, migrate to the latest version of my database. Run that. And it's telling me that there was a batch number 1 that ran exactly 1 migration. And look at that. My database just showed up in there. Isn't that cool? We now have a database. And if we go and open that database with, I close the browser for SQLite. Not a good idea. There you go. If we go and open that database, we'll see that it's exactly has the fields that we expected to. So I'm going to open the database. It's in here, courses, data, and here it is, db.db3. We're going to open that. And why are you still there? There you go. And you have this courses table in here. And if you expand that, you'll see that it's got an ID. It's got a name. It's a bar chart of 255. This is going to get translated into a text field. And the 255 doesn't really get respected in SQLite, but it's good that it's telling you this is what you're trying to do. Because if you move to a database that will respect the length, then it's going to be a bar chart of 255. Okay? And it is not null. Oh, look at that. This is a primary key, auto increment, not null, and it's an integer, and it's called ID. And it was created by default automatically for us. What do you think? Easy? Easy peasy? Lemon squeezy? So there's an error in there. Let's see if we can figure that one out. It's saying that table.increment is not a function. And I'm executing table.increments with an S. So exports that down is for rollback. Yes, sir. That's correct. So this setup is to wire code base for an internal portable update function for continuity down the line. Yes, is you're basically saying as my database evolves together with my code, I want to keep a record of that so that I can recreate the structure of my database at a particular point in time when doing development, right? And even in production, like if you want to move to a different server, you want to create your database, you want the database to be at the correct place. In some instances, some companies have more than one version of their software in production at the same time. So you might have a server that is running on version 3, and then you may have a server that is running on version 4, the new one, because you have users of both. And it may be that version 4 has a different database structure. So you need to be able to recreate, oh, I want to have another server for version 3. Well, you could go and pull down the code for version 3 and recreate the database from the migrations. And it's going to be exactly the way it's supposed to be. It's pretty cool for development. This is awesome when you're sharing code with the team members. But it's even more than that. I know you probably noticed that other benefit. So what happens if I migrate to now using MySQL? You remember Oracle? You remember that? All the code they had to write just to do, what was it in create table that we saw that? I think it was in create table. If you're doing this create table and you have this primary key, look at the little bit of code that you write, and that works. That's perfect. But what if you go back and then you switch to Oracle just because your company grew so much that you would need the fastest database in the world? Now, when you change that to Oracle, look at the code. If you were doing that manually, running script against your database, you now have to go and change that for every table. If you did it with migrations, though, all you have to do is tell hey, Connect, no longer connect to SQL, now connect to Oracle, and it will generate the right code for you on the database. So does migrate latest run any up that hasn't been executed or nothing and nothing else? Yes, sir. So your database is gonna know, because we have a table, and let me show you. This is not magic. There's this table called connects migration there. See that? So that connects migration knows, let's go and check out the data, browse the data, connects migrations. So I just click on this browse data up here, and you will see that it will know. All right, so the name of the migration is this. There's a batch number 1, and this is the migration time. So it knows the migrations that you already ran. So if I do latest again, it's not going to run anything. So I could run latest as many times as I want now, and it's going to tell me nothing changed. There's nothing changed. Already up to date. Already up to date. Right? So it knows that I'm already up to date. And the reason it knows is because of that table. And Connects, you don't touch that. Connects handles that automatically for you. Instructions and values, no. Values by values. So the question is, oh, there's another one before that. It says, did we have to say 255 just so that SQLite 3 can be converted to MySQL or something else later? Yeah, it's a good practice. If you're generating a schema where the information that you're gonna save is not unlimited. Let's say that you want to have the content maybe of of a book or something there. You know, it's gonna go on and on and on. You know how many pages it's gonna have. So if you're saving that in a field on the database, like the text for that book, this is a really bad example. Maybe you don't care about the size. So in that case, there's a value you could pass. Like if you're doing, I don't know, SQL Server, you could say varchar, but it's gonna be max. Like it's gonna be really, really big. Or there are field types that have no limit. Like it will grow as much as you need it to. But for other cases, like for instance, a name, you don't want to have a name that is way too long. So you give it a value here to control the size of that field, the length of the string field. So it's a good practice to have it, even if you work with SQLite. Because if you later migrate to something else that respects that, you already have that. Besides, remember, code, including this, is a communication medium. This is how you reveal to the next developer your intentions with this code. So this is kind of defining the specifications of your system right there. This is saying, in this field, we're going to save text information up to 255 characters long. Oh, I thought migration keeps track of both the structure and values of different versions of the database, but I guess it only keeps track of the structure. Yes, it's only for the schema, because what you're talking about is data. Imagine, like I told you, this database is over 60 gigabytes, the one that I'm dealing with now. Imagine that you kept copies of that. You don't. You keep the copy of the structure, because this is really good for development or deploying a brand new database. So you have the structure that is correct. The data, there are other ways of doing that. What you do is you do backups of that data. And most companies, like our company, the way that I had it set up is we had monthly backups, weekly backups, daily backups, and hourly backups. And in some cases, backups every 15 minutes, depending on the database, because depending on how critical the database is. If you have something, there are databases in there that they're continuously being replicated, but they're also continuously being kind of backed up every few minutes. So data is different from this. This is the schema, the structure of the database. So how will you name, change the name column to the first name? So I'm going to ask you this. If you were writing this, and I'm going to, let's say that we already have that, and we have the name column, right? And then we want to change that to be first name instead. What do? Every time you want to make a change, you create a new migration. Okay, so we say connects, migrate, make, and then we're going to give it a name. I'm going to say rename course name, the name column, right? So when I create that, it's going to give me a brand new migration file now. Should be in this folder. And if we open that, second migration, there's nothing there. Now I'm going to say return connects schema. But in this case, I don't want to create a table. I want to get a table. So, oh man, come on, Visual Studio, really? Schema dot table. I'm going to say I want to grab a reference to the courses table. And once I have that reference, and I'm going to call it courses just to show you it doesn't have to be called TBL. And now I can manipulate that table in there. I could do the same thing. Oh, well, hey, courses table. I want to, what would be a good name if you wanted to, let's say, rename something? I don't know if there are any extensions for Connect IntelliSense for sure. I haven't tried that. All right, so look at this. You have, for the schema, you have create table, rename table, has column, has table, table. See if you see anything related to columns. I'm going to scroll slowly before it goes out of view, really slow. If you see anything related to columns there that will let you kind of like change the name of a column, rename column right there. Look at that. Right? You say you have a reference to the table, you call rename column, and you say this is the name that it had. and I want it to be this name now. Of course, the documentation doesn't have an example in there. Let me give you one here. So rename column name, and I want this to be now called first name. I don't know why the course would have a first name. So in the down, we want to do the same thing, only backwards, right? So I'm going to do this, copy that, drop it down here, and change this to be first name here. And this is going to be name. Save that. And I'm going to show you something interesting. Now, I'm going to run latest. It's going to tell me, hey, I ran a batch 2 with 1 migration. So let's go and take a peek at our database now. I'm going to hit Command R to refresh it. Here we go. See, you have 2 migrations in here. And look at the batches, right? See, batch 1 and batch 2. 2 different numbers for the batch. And this is important because migrations don't run per file. They run per batch. And this is why when we run it, it's telling us, hey, we run the batch number 2, but we only ran 1 migration. And what this means is, if we go and see the structure of the database now, database structure, take a look at the courses table, the field is now called first name, right? We renamed it to first name. But then we realize, hey, this is a courses table. Courses don't have first name. It should be name. Roll that back. So then we go, and all we have to do is say connects, migrate, rollback. Run that. And since this is done by batch, it's going to say, hey, what is the last batch that we ran? Oh, batch number 2. And it's going to run that migration and run it back. So now if you go and check the database and we refresh, you'll see that the courses goes back to being named now. And the beautiful thing is that you could do that again. I could go back and say roll back again, and it's gonna, because all it's doing is going through the table, to the connects migrations table, and seeing which migrations is the next one that I should run, which is the next batch that I should run. So you could go one at a time. So it is a really good idea that every change that you're doing, you create a brand new migration, because they're really cheap to do. So you have separate migrations. I'll show you why. So let's say that I now go and do another rollback. Okay, rollback, boom. So if we go back, we try to refresh this, there are no migrations in there. Go back to database structures. There's no courses table there anymore. Okay. But going back to our directory, we'll see, and let me call your attention to the names. We named this courses table, and it gave us this weird number at the beginning. This is a timestamp. The idea is, it is trying to keep a history by using a JavaScript timestamp of what should run first. What is the first thing that you ran, and what is the second, what is the third? So it's doing it because it's going to go down this folder organized by the migration name. So if I come into this project now and I have no database, and I want to generate the database to this version of my software, what would be the correct thing to do? Should I run one migration? Should I run the last one? What should I run? What should be the migrations that should run? Oh, I'm going to give you time to follow along. I'm just trying to give you the idea. Yeah, if I run latest, what should happen? No, it should do everything, because the second one is renaming a field, but the table is creating on the first one. So what Connects should do is should run all of the migrations in order to update the database. So let me do that. Connects, migrate, latest. And look at that. It's telling me I run a batch 1, but I run 2 migrations instead of 1. So if we go back to our database and we refresh, we'll see that we have the courses table with the first name because this is how it was. This is the last migration that we created. And if you browse the data and go into the Connect migrations and refresh, you'll see that we have a couple of migrations that ran, but they ran on the same batch number 1. So if I roll back now, it's going to roll them back together. And that is important. This is why it's really important that you create new migrations as you go, as you evolve your database. Because this whole batch is gonna, if I do connects rollback now, it's just gonna delete the table altogether. It's gonna run both migrations back to the beginning. All right, your turn now. Your job is to create the migration, of course. Let me see, move this to the left. You're gonna create a migration that is gonna generate the table with the name column. And then you're gonna generate a migration that is gonna add a Boolean. So I'm gonna put some instructions in here. Add a Boolean field or column, let's call it column, called finished. That is the name of the field. And the type is going to be a Boolean to the courses table. I don't know how to do that, Luis. Well, your job is go and say, all right, once I have my migrations, all that, how can I, and you know now that you could just say connect schema, return connect schema table, grab the table, and then you make changes to it, like renaming a column. But you can also add a column to it by just defining the new column, and it will know that it needs to add it to the database. Now, the schema building section here on the schema builder, the schema building section here has a few things like big integer, text, string, float. See if you can find something inside of that schema building documentation that's going to help you create a Boolean field. By the way, a Boolean on the database is not true, false. It's 1 and 0, where 1 is going to be true and 0 is going to be false. But in JavaScript, though, we could just say, hey, I want this to be a Boolean. Go. Oh. What is the command for unique? I don't know. Go into documentation and do a search for unique to see if you get some results. You're going to get two, actually, right? One is where you define the unique, and another one is the chainable, but they behave the same. You just call them, and you give it a name. The name of the column you want to make unique, and optionally, you could pass the name of the unique index that will be created. We'll talk about that later. So I'm going to let you now kind of explore the documentations a little bit. So is a migration essentially like committing the latest changes for a DB? Yeah, kind of. Yeah, for the structure of the DB. That's correct. Can you roll back to a migration took place on a specific date and time? Nope. No. Not that I know of. I don't know if there is a way. There might be, but not that I know of. As far as the way that this works is, it will roll back one batch of migrations at a time, or it will advance to the latest on migrations that you haven't run yet. So going forward, when you say, hey, latest, you're telling it, I want the database to be how it was, like on the latest version of it. And then you can start rolling back from there. But nothing is stopping you from deleting these files. This is just files, right? You can delete that file. You can drag it out of there if you don't want a migration to run. But there is no way that I know of that you could go back to a particular place in time. The way that you do that is by going to a commit of your code at that point in time, because you always trust that the database was aligned with that version of your code, and then run the migrations from that commit on your actual code base, not the database. Can you roll back based on the timestamp like Rails? One at a time, as far as I know. I don't know of any way of saying, go roll back to this particular one. Not sure that's too useful. I don't know why Rails would do that, because you should always, when you're working with code, you should always be working against the version of the database that came with that version of your code. So it should be in your commits. Interesting. And then maybe they have use cases for that. When you do that, I'm going to create another migration here. Oh, so Sai says, in your example, it would be a nightmare to roll back to a version from a few months back. Not really, because what you do is that you pull a particular commit from your code base, and the migrations are there. So the version of the migrations that you have there, if you go and run, latest to generate the database from scratch, it's going to be up to that point, up to whatever database structure you had at that point on that commit with your code. It's going to move with your version of your code. And this is what you want. You don't want to be running a version of your code against a version of the database that is from 2 months back. That's not going to work. Or it shouldn't work if the database has changed. So the idea is you relied on your commits, because the whole idea of the migrations is the version of the database structure that you're going to work with should be in line with the version of your code at this particular commit. And this, having them in code like this, will let you do that. You don't run one specific migration. You run the latest migrations that you haven't run. You don't run one specific one. If you want to run one, what you do is you create it and then you run it. Like right now, I created a migration to rename this back to be called name instead. right? So I just run the migration right away. And I know that my database now is at the point that I want it. If I go back, this is how I wanted to have the database at this particular point in time, right? For refresh, should have name. That's the column that I want. And this feels weird because we're doing this within minutes, but this is not how this happens. You define the database the first time, you have all the structure. Like in this case, this is a 6-year system, and for the last year or so, they haven't touched this table that I had a problem with yesterday. But then last week, they made changes to the screen and they needed a couple of fields. So they added those. So that happened a year later. Since my version of the code, well, the problem is that they didn't have any migrations. So they're not using migrations. So I downloaded the latest version of the code, but I had an old version of the database. If they had migrations, all I had to do was to migrate laters. And any changes that they have done from the last version of the database that I have will be implemented in my version of the database. And it will work, and it's awesome. Is it safe to use ES6 with Connects? Well, Connects doesn't have any, well, I don't know if they have anything special about that. I don't have the answer to that. But I would say that it's safe to use whatever your version of Node supports, because this is being run on Node.js. So if you have one of the latest version of Node, 8 or 9 or 10, it should be safe to do things like this instead. Probably that's what you're asking. So if I do this, it should work the same, because my version of Node supports arrow functions, for instance. Now the key is there are things in functions and arrow functions that behave differently. Like, for instance, the binding of the this context. So what I don't know is if in any case, not on this, but in any other case, this needs to be a function like this because of the way that this is bound. Because remember that arrow functions bind in a different way, the this context. So I don't know that. I would say follow the documentation. Whatever they use on their examples, follow that pattern. This is why I had a function in here, because the documentation all over the place has functions instead of arrow functions. Just to be safe. So the Boolean column, we're going to add it to the same table. Oh, you're not going to modify a migration once it is. Oh, this is a really good question. Once we create a migration file, after we run that migration, we should not go back and modify it. We should create a brand new migration. If you notice, what I did was I had this migration that renamed this from name to first name, right? So instead of me going and changing this, since I already had run that migration, what I did is I created a brand new migration undoing the change, so that this runs, then this runs, and then this runs back and changes it. So after migration has run, the system doesn't know that you changed it. So after you run the migration, don't modify it. Now, if you roll it back, you could go and modify it and then run it again. That's no problem. But again, this doesn't really happen within minutes, like we're within seconds or minutes, like we're doing here. This will happen over months, maybe years. So what you do is, oh, I want to undo this change. I want to change this thing. You create a brand new migration and run it right away. Yep. So you're creating a brand new migration just to add that column, because that's part of the history. By the way, where's the, here. It's going to be called finished. It's going to be a Boolean. Cool. So we're going to go into a break. And this is not something, the only challenge here is that you have to go and read the documentation, right? So let me go and create it. so that you have a solution for this. And then we go for a break and come back and talk about something else, a seed, and then continue answering questions about migrations. So I'm going to create Kinex, migrate. I'm going to make add finished column, right? And finished column. Run that. And probably I will have a name that's longer, like add finished column to courses table or something. So we have that latest migration, and here I'm going to say, hey, return. Remember, always remember to return. That's important. Return connects migration schema table. I'm going to grab the courses table. Give it this table. I want to say table. This is going to be a Boolean. The name of that Boolean is finished. That's it. You could do this default to, let's say, 0, which should default it, but I believe by default SQLite 3 will not support that. Come on. The default 2. Remember that false is 0 and true would be 1. I think Kinex will do the right thing with that, but I believe this doesn't work. I've tried it, and I think it doesn't work in Kinex by default. I don't know if they have kind of a... All right, so now that we have this, how do I get rid of a column? Well, there is a drop column, so I could probably say drop column finished. They just do that. Where did I get that? Well, documentation has this thing, drop column, and I just give it a name, okay? And where did I get the Boolean? Well, there is a Boolean here. So I just say table, I want a Boolean, and then I give it a name, and that's it. Save that, and then I'm gonna run that latest migration. I should run one new batch 3 probably, yep, with one migration. And if we go to our database and refresh, we should have in there a finished field that is type Boolean, and the default should be 0. I don't know if that's going to work on SQLite 3. If I save, so the question is, what is the default to? Well, exactly that. If I don't provide a value when inserting a record in this table for the finished, it should default it to be 0, which is false on the database. Again, I think SQLite 3 by out of the box doesn't support this default to. So I think it might stay as null on SQLite 3. There may be an option somewhere in there like that you could turn on for that. I just don't know what it is. Okay, so this is hard to think about because it's not dry, like do not repeat yourself. But it's meant to have a timestamp to schema changes. It's not meant for version control like Brock said, right? Well, I'm not sure I understand the question. Let me rephrase again all the things that I have said so far and see if we could get an idea of this. This is a way for you to register every change to the structure of your database in code that you can then commit to source control. The main advantage of this is that the versions of your database schema are going to move together with the versions of your software. So the idea for this tool or the process of using migrations is that you come later, a developer comes in 3 years later, and it needs a database that has the structure of, the database that in particular commit. Let's say that you come in and you're going to work on version 3.2. But the current database, if you do a backup and you give it that, maybe has a different structure right now. So you tell them, hey, download the branch for version 3.2 and start working. They need a database. How do they know how was that database 3 months ago? They don't. But they can recreate it by just saying, hey, migrations, latest. And now they will have a database with a structure at the point that that code was committed to source control. I know this is hard to picture. I don't know where the dry comment comes from. Don't repeat yourself, because that's exactly what you're doing. Instead of having to do the things over and over again with the database, you just run a command and it will automatically or magically assemble a database for you with the right structure for that version of the code. So why do they come in pairs? Well, because you need to have the ability to roll back a change. It's like undo. So if you go and run migrations against a database, and then you start testing it out, and it turns out that, oh, well, actually that was not a good idea. What can you do? Well, you could just go on, let's say that you're dropping this column or this table. You go and create a table because you're going to work on something, right? And you're testing it out and you create the migrations, you generate the table, you start working on your system. And then the team decides that they don't need that table anymore. What you can do is you could go to the database and delete it. But then how does somebody coming later into this code base at that point in time know that that table is not there anymore? So what we're telling you is, instead of going outside of your code and secretly changing a column, renaming a column, or doing things like that, that is not reflected on your code base, so people will not know, only the people that did it know, because they went to the database and renamed it and changed it and changed the size or deleted that table, you register that as part of the migration. So you can always go back and say, hey, I'm going to undo this change, but you do it through the migration. You say migration, roll back that change. So anybody can come in here now and know about this. These are things that could be happening to a database in production. So if you're going to rename something on a database, but you need to roll back the change to undo it, then you could just undo it through the migrations too. And this is going to generate, remember, this is all going to do whatever it needs to do it on your version, on the database that you're using. It is useful, trust me. Mm-hmm. So where do you find information on the terminal command? Add finish column is a name that I gave it. That's the name that I gave it. When you do migrate make, you give it a name so that you have a name for the file. What I tend to do is give it a descriptive name. So when I see this, I say, oh, this creates the courses table. This is going to rename the course name field. This is going to rename the course first name field, and this is adding a finish column. It's just a name. So what Connects does is it adds a timestamp at the beginning and then the name that you gave it. This is for me, that name. So SQLite doesn't have a separate Boolean. Nope, it does not. It does it as a number with a value of 1 or 2, or 1 or 0 for true or false. All the databases do. So every database migration have an associated version of, well, this is part of, this is just JavaScript. So the question is, should every database migration have an associated version or commit in source control? Yeah, sounds like a good idea to me, right? So if I do and create or rename a column, and I want to make sure that I can always go back to that particular point in time, yeah, do a commit. Remember, the rule of thumb is commits are cheap. Pushes are cheap. It takes seconds, literally, to do a commit. So every time you do something meaningful, and in my head, changing the structure of my database is something really important. So every time you do that, you should do a commit, for sure. What I don't think is a good idea is to, let's say that you every time you do a migration, you change something on the database is because you want to accommodate a piece of your code. So what I don't think is a good idea is to just create a migration and just do a commit for the migration itself. I would say if you add it because you're working on a particular feature that you added, like, I don't know, a checkbox to the page or something, and you did the migration as part of that because you needed that field on the database, you finish that little piece of functionality, and then you do a commit so that you not only have the change to the database, but you also have the change to the code that needs that change to the database. So they move together. You think of it as a piece of functionality, even if it's not totally complete, but if I have like the first MVP, the first version of it, work in progress, you do a commit with that so that the code and the database go together always. These are really, really good questions. I have 4 migrations. Oh yeah, you have 4 migrations because I created one to revert the change on the first name to name. Another alternative would have been to delete this in our case. I delete this field and then delete this other field because we don't have any code associated with that particular version of the software of the migration. So, but the practice, the good practice is I change something, I continue working on the software, I have versions of my code that depend on that change, and then I go back and I revert that change on the database because my software changed. You create a brand new migration. You don't remove the old migration because you have code that depended on that migration, on that structure in the database. So you create a new one. So this is what I did. I mimic that by saying, hey, later, 3 months later, after my software was always referring to that first name column, we decided to change it. So when I implement that change on my front end or my back end that is not changing that column name, and I changed it on the database, I write a brand new migration to do that. Let's take a break. All right, let's take a 5-minute break and then come back and continue answering questions about this. I think this is one of the concepts that you have to kind of like follow it up on faith in the beginning, because it's hard to show the value when you're working within minutes and just making changes every few seconds. This is really valuable later when you're going through the history and making constant changes to software over time. So all I'm asking you is learn the mechanics of it, and learn it on faith, because it will be really useful for you in the future. So let's see you back in about, let's reset it. See you back in 5, and we'll continue answering questions. And we're back. All right. So there's another question there, and I like this line of questioning because it's aiming at clarifying the concept. Like, I need to understand this. So once you know you need to roll back a migration, do you write a brand new migration to do it? No. If it's just a rollback right there and then, and the code that is going to use that needs the rollback, you can roll it back. Okay. The idea of creating a brand new migration is I'm going to do a change on a migration that already has code committed that was using that version of the database. So I'm going to give you an example. Let's say that you have a front end, and the front end has, let's say, this list of releases. So your database reflected in this version of GitHub, reflected the need to have those releases, a release collection. But then later, the development team, for some reason, decides, yeah, we're not going to handle releases, and we're not going to keep a record of the releases anymore because people is not using this feature. We're just going to remove it. So you go into your code, or maybe they changed this somehow, right? The idea here is there was a change later down the line where we decided the stuff that we're using this particular piece of the database for, it's going to change. So you changed your UI. And probably now it doesn't really need the releases. And a lot of the process that you had that were running and they were changing and doing things to the releases, those are going to change too in your code. So what happens to your database? Well, it's got to reflect those changes. So do you do a rollback? No. You write a brand new migration that says, now I have to update my database again so that it reflects the reality of my code, the needs of my software. So that's where you do a new migration. But if you're doing is that you created a migration to test something out, and then you write code for that, and then you decide, no, I'm not going to use that. But you already migrated the database. But then you undid the change on your code, so you don't need that migration that you just added just right now. You don't have any code in production that depends on that. Then of course you could just say rollback. So you roll back the database, and you can even delete the migration file because you're not going to use it. You don't need that anymore. But no code was shipped to production or was not pushed to the repository that depended on that migration. This is something you're doing locally while you're testing something else. So you change the database, go and test something else, and then you decide, nah, I'm not going to do that. So what do? You scratch the changes on your code. You haven't pushed anything. You just scratch the changes on your code. So you also roll back the database so that the database changes back to what it was, and you can even delete the migration at that point because you're not going to use it. And then you do your commits. The cool thing is that as you start using them, it's going to make sense. You're going to know exactly, intuitively, you'll be like, yeah, I'm gonna add a migration for this just to keep a record of that with your code. So let me see any more. Okay, that was answered. Cool. All right, so let's take a quick tour of the project of this afternoon. This is what you're going to be working on this afternoon because we need to cover a couple of things before I let you go, right? So the idea is you're going to, and again, you're going to be like, this is so short. There's no instructions, almost barely any instructions. Tomorrow, just to make you feel better, tomorrow is going to be worse. There's going to be even less instructions. And that means we're treating you as a developer. You're going to get more flexibility and you're going to come up with the solution, make it up, make it happen, right? So in this case, you're going to build an API. It's going to persist to SQLite 3. This is part of the requirements because this is the database system that we use. You're going to use Connect migrations. You're going to create a database called lambda.sqlite. Our code expect that there's going to be a lambda.sqlite 3 database in there. So this is what I'm asking you to do, the assignment. So you're going to create a table, the following tables, cohorts and students, and the cohorts is going to have an ID, primary key, auto increments. The name is going to be a text field and is required. Students is going to have ID, primary key, auto increments, name, text required, and the cohort ID, and this is the part that we're going to cover right now in a minute. The cohort ID is going to reference the ID on the cohorts table. This is called a foreign key. So we'll talk about that in a minute. And of course, tomorrow we're going to go in a little deeper into data modeling. So tomorrow is when we kind of really understand that. Today, we just mechanically are going to show you how to do that. So you start getting familiar with the syntax of how to do a reference, a foreign key to another database. But tomorrow we talk about relationships, the importance of foreign key, the constraints, how to keep the integrity on the database, and then we go deeper into why we're doing this. So concentrate today on just writing the code, have a sample code, and implement that on your project. Get used to the syntax. And then we're going to use this connect seeding feature that we haven't done yet. So we have about half an hour to do both. Seeding feature to test, to add test data to your tables. So this is for development only. You're not going to do that in production ever. And then you have some endpoints that you're going to write. The good news is we already know how to write those endpoints. You know, get by ID, you know, how to do sub-routing, you know, get by ID and then just get the list of students to return all the students on the particular cohort. And then you have a stretch problem if you want to go in there. So a couple of things we want to talk about. How can I do foreign keys? How can I do this reference? And how can I do seeding? Let's do seeding first. Questions about the project first. Really, really important that you read the instructions completely. Because a lot of the time, what you'll be getting is written instructions on a requirement, and you want to, you know, implement what the client or your company needs. Okay, cool. So seeding first. Well, turns out, remember that if you do connects, and even if you do connects-h for help, it's going to tell you, we have this other third command called seed right there. So how do we use that? Well, the idea behind this is I come into the project, I want to have some test data. Like I want to spin up the database with courses, and I want a couple of them so that I could start writing endpoints and have some test data in there by default. How can we do that? Well, easy. We could say connects, seed, and then you see that we have a couple of them. We have make and we have run. So make, same as the other one, and give it a name. And here's where it changes a little bit. By the way, let's go back into, before I run that seed, let's go back into our connects file. And you see how we have this migrations directory? I'm going to copy that and create one, but for seeds. So instead of migrations, it's going to be seed. So for the seeds, the directory is going to be seeds instead. Okay, and that's data seeds. So after I save that, now when I create my migration, and here's the thing, on the migrations, I'm sorry, when I create my data seeding script, in the migrations, you get this timestamp by default. You don't get that on the seeds. So the order is really, really important, because later, let's say that you have a client, and the client has, let's say, orders. But you need to somehow know, for this order that I have on hand right now, who's the client that wants it? So you need to have a relationship between the order and the client, where you say this order belongs to a particular client, and a client has a set of orders. In your database, you have to reflect that. So when you say, give me the order that I'm going to ship, and you need information about the client, like the address and all that, you can navigate from that order. Somehow, you're going to have a reference that points to who is the owner of this order, who is the client. Okay? Why is this important? Well, because if you have an order, and the order says that belongs to the client with the ID of 3, and then you go and check on your client's table, and there is no client with the ID of 3, now you have an order and you don't know who it belongs to. And when that happens, you have data that is inconsistent. It's garbage. You have an order and you don't know who you're going to ship it to, who you're going to charge it to. And it's even worse if it's an order that you already delivered and you no longer know who to charge for the order, who's going to pay for it, right? So that means that in order for you to be able to add an order, and assign it to a client, first you need to have that client on the database. The client must exist. So when you're adding data, test data for your use, you have to make sure in that scenario that you add first a client and then you add the orders for that client. This is going to be more important as we do multi-table stuff tomorrow. But for today, just trust me, you want a number and you want to order manually the order in which your scripts are going to run on the seed folder. So what I normally do is I say, let's say that this is my first script and I need this to run first. I just give it a number, and depending on how many scripts you're going to have, you give it one position or 2 positions. I'll assume that I have less than 100. So I'm going to call this 01, and this is going to be for the courses, right? So this is going to see the courses table. Click that, and it should have created a seeds folder right here. And there is this file here that says courses table. And you can rename them. I mean, it's just, at the time of creation, you could just give it the right thing. And if you see later that you want to reorder them, you can reorder them by changing their file names. So what are you getting here? Well, all you have to do here is say, okay, what's the table that I need to add data to? Seeding is just adding test data. And in this case, it would be courses. So you change it on both places. You change it up here, and then you change it down here. Okay? Now, the other change that I want you to do is instead of using delete, I want you to use something called truncate. So you will say, on the courses table, I want you to truncate that table. And then I wanted to insert this list. And this is just as a regular array with the objects. Now, do I need to provide an ID in our scenario? This is a question for you. Do we need that ID right there? No, we don't, because it's going to be generated by the database. So we could just delete it. Get rid of that. So what is the name of that column that we're using? Well, in my case, it's called name, because I wrote a new migration to rename it back to being name. So I'm going to say for the name, this is the value that I want to add, right? And then you just add any values in here. This is just test data. So you could say, I don't know, let me go back into Slack and say Patrick. And then here, we're going to have Michelle. And then here, Brock. And I know these are courses, but ignore me. They're going to teach some courses for us. But we also have another value, though. We have another new field that we add that is called finish, is it? And then let's try this. Let's say true on this first record right here. And then on this one, let's say false. And then this one, we're just going to leave it empty. Save that. Okay. So only thing you need to know is that you could do seed make, give it a name. You should number them in the order that you want them to be executed. And then change the table name in both places. And then on the insert, just pass the data that you know you need to pass to your database. So the ID doesn't have to go if it's auto-generator. Anything that has the default value, unless you want to change that default value manually, should be okay. Now let's try it out and let's see what happens. So Patrick is true, Michelle is false, and Brock has no value for the finished property. Let's run it. So to run it, connects, seed, instead of latest, it's called run. Run that. Hey, see the one file. So we should have some data on the database in theory, right? So let's go back and say, take a look at our database, refresh this, go into browse data. Oh, look at that. We have data. But we want to see the courses table. There you go. You see my point? SQLite, for some reason, will not respect that default value. It's just going to leave it null. And it's fine because this field is not marked as not nullable. So as you can see, the finish, this is true, this is false, and this is just empty because we did not provide a value. But the beautiful thing is we have data already. So if we run our server, is it running already? I don't remember if I have it running. No, we don't. So let's go add new terminal here and say join server. Here we are. And if we go do a get, this is the stuff that we have in there from our database. Look at this, finish is null. Now, what happens if I need to, recreate this thing? What if I go in here now and to my delete? Let me see what we have. We have 1, 2, and 3. So what if I go in here and I delete number 1? Because I'm testing, delete number 2. SQLite busy? What do you mean? When SQLite is busy. Is this? Oh, there are no change. There were changes that I did here without knowing. All right. So let's try this again. Delete number 2. All right. Delete number 1. And this is you just doing testing, testing your code, and you delete the data. But now you're like, oh, I wanna refill the database again because now I need my test data again, right? So you want your test data again. How do you do? Well, you go back and you say, hey, I want to reset my data again to have my test data reset. So I run my seed again, go back, and voila, my data is back, or my test data is back. So I can now modify this as much as I want because I know that I can always go back and reset it and have it the way that I want it for testing. And the beautiful thing is that as you migrate your data structure and you add test data for development purposes, that's going to be there. So when you do your commit with the feature that is using that and using test data, all of that code go together in that commit, and you can always recreate it. You recreate your full database, and you have your test data there, and you can start just testing your software and making changes to it. So Brian said no. It's probably to answer something else. This is really useful, being able to just seed your data and have it in there. So that's seeding, really, really simple. Seed, make, give it a name, make sure that you order them. This is going to become important tomorrow. So today, just name them, whatever. Then coming here into the generated seed file, right? We did make a little change here. We changed, we added this key so that we control the directory. Otherwise, it would have just created a seed directory outside. I want this to be inside the data folder. That's why we changed that. And then you go into your seed file generator and you add the data, just JavaScript objects with the values that you wanted. So let's fix this. Finished, false. Like that. And Kinetics is just translating that into what the database needs, which in this case is going to be a 0. So if I run that again, seed run. Oh, by the way, we changed this, remember, to truncate. And the reason we're doing this is a command that you run on SQL databases so that the ID key gets reset to 0 again. And it's going to begin at 1 again. Because this will become important when you add test data and you want to add orders pointing to ID number 1 on the client. If you leave it as delete, what it will do is it's going to delete the records, but the key is going to continue to grow. So it's going to go 1, 2, 3 first, and then 4, 5, 6, 7, 8, 9 every time you run it. And you don't want that because you're going to have some data that is related to this table that is going to assume that in this case, this is going to be the ID of 1 and this is going to be the ID of 2 because they're inserted in that order and everything begins at 1. So when I want to add orders to Patrick, I'm going to assume that he's got the ID of 1 all the time. So this is why we changed this to be a truncate instead. I'm not going to have you test it, okay? Just because I want to show you how to do the reference. But tell me if we understand the concepts, because that's what's important. The rest is just syntax that you're just going to copy this as I give you the zip file. Do you use seeding outside of testing? Yes, you can. You can use it. I'm going to give you an example. When was the last time that the states on the United States changed? So if you're creating a brand new system that have no data in it, there is no reason why you should force your users to have or write, let's say, a piece of software so that they can import those from Excel or whatever, or have them just add them manually. So what do? Well, you have it as part of your software. You create a seed file that is going to populate the states, the cities, the zip codes for a particular city. If you already have that data, you can have it as part of this. Because now, any developer that wants to recreate a database and have those things that are kind of slow to change, let's call it that, you can have that sample data in there, but you can also use that data in production just to wire up the database with some useful information out of the box. Like, for instance, some companies have states, active, inactive, deprecated, things like that. So those are pieces of information that the company already decided that they're going to have on the database. So you could just seed those as part of the process going to production. But it is the most useful for testing for sure. Oh, so you mean that it continued to add? So instead of having 3, you have 6 now? That's because you're missing that truncate over there. So the question is, hey, I ran this thing again and I have the whole list after deleting. Yeah, tomorrow. Yeah, the question is, are we going to cover joins? Yes, tomorrow. Because tomorrow we talk about, data modeling, relationships, and then joins comes after that. As you know, you have more than one table. How do I get data from them? Yes, for sure. For sure, for sure. So Jeanette, make sure that you have this truncate at the top there. Return connects, truncate, and then you add the data. This will clean up the table for you. And then just wrote the seeding again. All right, so let's go and see how to do this. And I'll show you how to do it, right, for the project. And then tomorrow we'll understand why we're doing it. And the idea of this cohort ID, okay? So for that, let's go and create, let's imagine that we had another table for the courses that is called schools, right? And then the school has different courses, or maybe tracks, and then each track has a few courses in it. So let's create a brand new migration real quick here to have tracks. So I'm going to say connects, migrate, make tracks table. And this is kind of now becoming maybe students. So now we have this new thing, and this happened a few months. We decided that we're going to have tracks now. So our code is expecting that we have tracks on the database. So here we go and create a migration. We'll say return connects. I should just probably copy that schema. Yeah, wow, this is bad. I'm going to create a table called tracks, and then this is going to be increments. And of course, it's going to have a name. And we want this to be unique. So I'm going to add later, I'm going to say the table that unique. And for this table, I want the name to be unique. And I'm going to let, Connect generate a default name for that, unique. So I'm just saying this field that I have right here, this name field, is going to be unique. Okay. And also, I want this to be not nullable. I want to have a name in there. And how long can this be? I don't know, 128 characters maybe. I think that's good for now. That's all we need, right? So we have the ID and all that. And then down here, return connects schema, then drop table, tracks. So why is this unique important? Well, because I don't want to have two tracks with the same name. And if you try to insert a second track with the same name, you got to get an error back from the database, and then you could capture that error on the catch of the promise and look at the error code. It's going to be error number 19 in this case. It's going to say, hey, you're violating the unique constraint when you see that error number 19. And then you could say, hey, if the error number is 19, you could send a message back to the user, say, this already exists. Okay. So now that we have the tracks, all we have to do is run the migration. The latest migrations should generate that table for me. And then we're going to create a seed for that. So connects, seed, make. And look at this. Now, I want to have this run before I run the courses, because the courses are going to belong to a track. So I'm going to say 01 tracks. And you're like, hey, but the other one is called 01, Luis. Yeah, I know. So tracks, we have this track here. So I'm going to just rename the other one. Cop out solution. So tracks is going to run first, and then the courses. Okay. So let's go and sip some data in here. First, we don't need the ID. I wish they wouldn't provide the ID because we don't normally need it. So let's get rid of this. And then we have the name column. And then we're going to say our tracks are machine learning, computer science. And also, of course, we have web development. Okay, and that's it. And since these are all different, we're not going to have a problem with our unique. Remember always to change this delete to be truncate, because this is what's going to guarantee. Oh, let me show you the difference. Yeah, this is important that you see this difference, and I know we're 7 minutes to go. So I'm going to leave the delete in this instead of using truncate. So tracks, and you'll see the difference between the two. So as we run the seeds, seed run, it's going to run them both, right? The tracks and the courses, and I'm going to run it again. So I ran them twice. If we go look at the data now, where's my DB? Oh, close DB browser. Here's this one. Yeah. If you look at browse data up there and look at the courses and refresh, you'll see that the IDs are 1, 2, 3, even though I ran them twice. But if we change the table up here to be tracks, you'll see that the IDs are 4, 5, 6. And this is because I ran it twice. So when it deleted the first one, it did not claim the first 3 IDs. It would just continue incrementing the ID. And that's a problem, right? Because what I want to have now is I want to say that I want to assign, let's say, the 3 courses that we have to web development. So this ID has to be, for the purpose of seeding test data, have to be consistent. It's got to be always the same ID, because I'm going to be doing a reference to the ID on that table. So how do we fix it? We say truncate. We save that, and then we can run our seeds again as many times as we want. I run it a couple of times, and still, when we refresh, we have 1, 2, 3. And we refresh again, we always going to have 1, 2, 3. So I now can rely that the ID number 3 is going to be for web development. Good? Okay. All right. So the idea here is that I want to take, now that I have this tracks table, I want to relate my courses to that table and say that all of the courses that I have here belong to a particular track. So at the end here, I'm going to add a column called track underscore ID. And here we're going to save the ID of the track this course is going to be associated with. And I'll say that all of them are associated with the number 3. So they're all on the web development track. Now, we need this track ID though. We don't have it. So we need to go and create it. I kind of hate those names like that. So, all right, let's just create it like that. So we have this track ID. So we need to add those fields to our database now. What do? Our application now has this relationship and the code depends on that relationship to exist. So we have this new data table that we created. What should we do now? Yeah, we need to add that foreign key, but how do I do it? Do I go to the database and just add the foreign key? Yeah, another migration, because now I have code that depends on that field existing and being related to the other table. So since my code depends on that, when I do the commit for this feature, I am expecting that the database has that information. So what do? As part of this commit of the feature, I'm going to make sure that I record the migration needed on the database. So the first thing is, one, create a migration for that. Add track ID, foreign key. And I know this is not fully strict, there's saving time, right? So now we have this one right here. Let's go borrow. Nope, not this one. Let's go borrow this code right here because it's going to be fairly similar for our new migration. So I grab my tracks table, my courses table, not the tracks table. I grab my courses table, and instead of adding a Boolean though, what I'm going to add is, and this data type has to be similar to the data type. It's got to be the same data type on size of the ID field or the primary key field on the table that I'm referencing. This is how foreign keys work. So you have a primary key on the parent table. In this case, it's going to be tracks. But then all of the courses are going to be pointing to that. So the data type has to be the same. Because what's going to happen is the database is going to kind of do a triple equals, if you could think of it that way in JavaScript, between those values. It's going to say, okay, so what do you have on the courses table? Oh, you have a number 3 here. So it's going to do a triple equal and say, give me everything on that table over there that is referencing here, which is the course, the tracks table, where the ID field also has the value of 3. And those are related that way. So the values has to be the same type. So in this case, it's got to be an integer because the primary key is an integer. And the integer, the name of that field we said is going to be track ID. And this is something that you're going to add, right? It's called onSign. This is basically saying this integer is not going to have negative numbers because you're going to start at 1, so you don't need negative numbers. And this is important for databases like MySQL, for instance. So we're just going to add in there, even though for SQLite it's not doing anything. But then, this is where we add the reference. Let me extract this out so that it's easier to read. So always add the onSign, just in case you move to a database that need it. And then you're going to say, this is going to reference, and there are different ways of doing this. There is a foreign that you could do, but I like the one that's called references. It's going to reference the ID field in table tracks. I just like the way it reads. So I'm saying, hey, courses table, I want to add an integer field that is going to be unsigned, and it's going to reference the ID field in the table tracks. And here's the name, by the way. And then here, when we drop the column, we just drop the column track underscore ID. This is trickier than what it looks like, because this is going to become a foreign key now. We'll cover this later because we're already on the time. So now we could just run the migrations. There you go. Foreign key and primary keys not only may only be added on create. Yeah, I know. Oh, SQLite 3, he doesn't like it. Okay, so see what it says? It says, well, on SQLite 3, this is very useful. I didn't know that, or forgot if I knew it. It's telling me, yeah, you can. Oh, yeah. I know why. It is because this is doing an alter table. So, unfortunately, in this case, we can, because it's SQLite, we can really do that. So, what can we do? Well, in a test environment like this, where you're using SQLite, you can always go back, either do it manually or just scratch the database altogether and recreate it again. Okay. This is unfortunate. I wish there was a way around this that was simple to do. So I'm going to take the easy way out. I'm going to go back in here to the first migration and say, this is the courses. I also want to have this thing. No, I don't like it. I kind of hate it. Kind of hate that concept of not being able to do it later. Okay, so let's do that. So you see how it works. So the idea here is, when you create a table, this is how you would create the reference. So keep that. Let's not run it. We'll talk about that tomorrow, because I have more time to go over that. So I'm going to ignore that. I'm going to assume that it was created, right? So the idea is, I want you to understand the code to create it. So this is a limitation of the database that we're using, that you cannot do an alter table that way. I don't know if there's a way that you could do it raw, but like writing pure SQL instead of using the JavaScript. So the idea is, all you have to do is, as you create a table, add a field that is going to be an integer unsigned, because it's going to be pointing to that integer on the other table, that references the ID on the table tracks. I'm sorry, I forgot about the alter table thing with SQLite 3. So add your reference when you're creating the table. So add it here at the beginning. It would be like this. Only in this case, we need to create first the tracks table. It needs to exist in order to do that. So you would create the tracks table first. So let's do this. Let's rename this just to see it running, right? It's going to rename this to be the first one that runs. So once this runs, then we're going to create the courses table, and then everything is going to run from there. So we can remove this migration. So all I'm doing is reorganizing so that I can create the tracks table first, and then the courses table that is going to do that reference, so you could see working, okay? And since we have all of that there, we can just drop this database altogether. Oh, wait a minute. I have it open here on DB browser for SQLite. So let's close this. And now let's go drop it. All right. And then let's do migrate latest. And they should run, create a tracks table, create a courses table. And the courses table now is going to have a reference there, and then do all of the other changes that we did, including adding the columns. And now we could run the seats. This is so good for testing. So malleable. There you go. So run the seat file. And if we go back now and reopen our browser for SQLite, we do have both tables. And if you look at courses, now we have this right there, this track ID field that is an integer, the way that we expected it, and it should have created a foreign key. If you look at the create table up there, look at this. So foreign key, track ID, references tracks on the ID field. You see it up there? So it knows exactly what to do to create a foreign key. Unfortunately, SQLite 3 will not enforce that by default. We have to pass a flag for that, but it works. It creates the database, and it will tell you, it will tell the database, I want this foreign key to be in there. And there is data. So now, if you go and look at the tracks, machine learning, computer science, if we go and look at the courses, and we refresh, hey, it is not, hey, I didn't run my migrations? Why didn't it see the data? Oh, wait a minute. What just happened? Oh, I only have the tracks. What happened to my seeds? Oh, did we not save that? What did I do? Well, I deleted it apparently. I deleted the seeds. Sorry. So just create the seeds and add some test data in it. And that's it. Yeah, I think I deleted it by mistake before. So if you add the new seeds, number 2, it would add the seeds for the courses. So I will give you this, and just as you create your tables, make sure that when you create your second table and the moment of creation, use this code right there. Okay. So make sure that you add the reference there. Just because we're working on SQLite 3, this is not a limitation on other databases. It's just SQLite 3. Is there a way to see the SQL getting outputted by the migration? There is a debug flag that we can set, but I don't know if it works on the migration. I've never tried that. Should be interesting though. So, and I think you could pass it on the command line too, but there is a debug true here. I don't know if that does it though. I have to check how to do that. I'm sure there is a way of doing that. Oh, there it goes. Yeah, so that debug true, it's just telling me what we're doing, and you can have ideas of what's going on. Oof, there's a lot of code. So the first thing is doing select from SQLite master where type table equals this, and the value is connects migrations. Let me see if we select name. It's doing a lot of commands in order to make those changes. Not as helpful as we thought, right? There is also a SQL, but I haven't done that. There's also a to SQL and to SQL native to SQL.native that you could call on the commands that you do. I don't know how to, if you could do it on this one too. That will actually output that value for you, and it's gonna give you the actual string that you execute. It'll be interesting. If I figure it out, I'll let you know. Sorry. Never try to do that. All right, so that's it for me. I'm gonna give you a zip file for this. Go work on the project. If you get stuck, don't worry too much about it. But hopefully you should be able to just complete the project for today. And then tomorrow we talk about relationships at a deeper level and how to use joins and all that. So I'll see you tomorrow. This is not easy stuff.